Hello and welcome to Calsoft's podcast series. My name is Umang Rajvanshi and I will be your host for this podcast. I am associated with Calsoft as a marketing specialist. Today we have with us Mr. Sachin Mali, who is veteran technologist and will be discussing Nfs protocols and traditional file systems with us. Sachin is a senior QA lead at Calsoft. He has 13 plus years of experience in the IT industry and has major experience in storage and virtualization technology. Nfs protocol and virtualization are his major strengths. Today Sachin will be throwing lights on DFS, Nfs protocols, Nfs all versions while providing a brief about their features. He will also be discussing in details the traditional file systems. Hello Sachin, it's pleasure to have you with us.
Thank you.
So let's quickly get started. So can you just briefly explain us about DFS and traditional file systems?
Sure, Oman. As we are having a talk on NFS file system, so it is NFS file system. It is also a type of distributed file system. So we should have to understand what exactly the distributed file system is. A distributed file system is which store data on server. It is basically client-server based architectural file system. In that, data is accessed and processed as if it was stored on the local client machine. A distributed file system make it convenient to share information among users on the network in a controlled and authorized way. The server allow client user to share file and store data just like they are storing the information locally. However, the server have full control over the data and give access control to the client. If I want to talk about the file systems, it's a traditional file system. So a traditional file system is a method or a set of rule retrieving informations from the storage medium. Without the file system, information placed in a storage medium would be one large body of data with no way to tell where the one piece of information stops and the next begin. There are many different kinds of file systems are available in the market. Some file systems are used for local data storage. Some are provide network data access, just like NFS or SMB. Some are virtual file systems, just like ProcFS or SysFS. Each one of has a different structure, logic, property of speed, flexibility, security, size, and many more. Some of the file systems have been designed to use for a specific application, such as the ISO file system, ISO 9660 file system. It is designed specifically for optical disks. Now, we have to understand file system layer through which data travels in a common flow for all the file systems. There are three layers. First one, logical file system layer. It is responsible for interaction with the user application. It provides file operation and passes requests to below layer. Virtual file system is the second layer. It allows support for multiple concurrent instances of a physical file system. And the last one, physical file system layer. This layer is concerned with the physical operation of storage device, that is disk. It processes physical block being read or written. It handles buffering and memory management and is responsible for the physical placements of a block in a specific location on the storage medium. Now I can consider with this brief explanation, you might get an idea about the file system. Now we can move our discussions towards NFS protocol. In early days, when Sun Microsystems was in the process to find a way to share file folder over a local network, that time NFS protocol got invented. It was the first version of NFS protocol that is called as Nfs V3 version 1. But later on, Sun Microsystems has made this invention to open source so that the community also helped to grow this protocol. Now lots of companies enhanced this protocol and made it as a proprietary protocol, such as NetApp or EMC. Presently, there are 3 versions got standardized. First one, NFS version 3.0, second, NFS V4.0, and third one, V4.1. V4.1 is a minor version of NFS V4.0.
Sachin, can you please explain these different kind of versions, how they are different from each other?
Definitely. So we will start our discussion with Nfs V3. Nfs V3 is a widely used NFS version. It has many enhancements over Nfs version 2.0. I'll touch upon few things about Nfs V3. First of all, it is a stateless protocol. It means server is not maintaining any state of the client. Second, it works with a few sideband protocol. Sideband protocol means like such as port map, mount, NLM, NSM. Nfs V3 cannot work individually. It will if any of the protocol is not available or blocked by the firewall, then Nfs V3 will not work as expectedly. Nfs protocol work on a file handle. Nfs V2 uses the fixed file handle that was 32 byte. And in Nfs V3, it improved by introducing variable length of file handle that is of 64 byte. Because of that change, user can read file more than 2 GB. In Nfs V3, asynchronous write call got introduced, which improved the write performance. In Nfs V3, there is one RPC procedure. StateFS got removed and 7 new procedures got introduced. Those are access, mknode, readdr+, fsinfo, fstat, pathcon, commit. Now I can consider you might get an idea about NFS protocol and its feature. Now we will discuss more about NFS V4.0. When NFS V3 got widely accepted from the customer, then some limitations also come across, which were become the reason to develop NFS V4.0 protocol. This protocol has lot many enhancements over NFS V3, such as V4 introduced Kerberos support. ACL also got introduced into V4.0. Then the locking delegation feature made in NFS V4.0, and those features made NFS V4.0 stateful. To improve performance, compound call got introduced. A compound call means it multiply procedure and send it to the server with only one RPC request. In one RPC request, what are the calls are there? First one, lookup, open and read. Those are in one component RPC request. Another feature is the file migration, replication and referral also got introduced in NFS V4.0. Locking, there is an enhancement happening in locking. So in NFS V3, there was a fixed locking were there. So now in NFS V4.0, they have introduced the lease-based locking. Also, the virtual storage feature also got introduced into NFS V4.0. Now we can discuss about V4.0 features. So as I told you, NFS V4.0 has the minor versions like NFS V4.1. So very minor features got introduced in NFS V4.1. First one, parallel NFS got introduced into NFS V4.1. Also, directive delegation is also introduced, and one RPC call got introduced, that is reclaim complete is introduced in NFS V4.1.
How is NFS fits into OSI layers?
Yes, that is important. As of now, everybody knows what is OSI layer. Now we will see how NFS fits into each of the OSI layer. To just have a brush up, I'll tell you the OSI layer. First one is like physical layer, data link layer, network layer, transport layer, session layer and presentation layer. Now we will see how NFS fit into each of the OSI layer. In physical layer, there are hardware comes into the picture. In data link, Ethernet will come into the picture. In network layer, IP addresses get into the picture. In a transport layer, TCP UDP come into the picture. Then session layer, RPC means remote procedure call come into the session layer. And the presentation layer, the XDR protocol will come into the picture. XDR means external data representation. Also there is the application layer, and Nfs protocol, network file system protocol, works in application layer.
How NFS mount happened?
Yes, we should have to understand whenever we are mounting any of the NFS volume, so we should have to understand how NFS mount happened and what are the processes happen. So first one, when any client send a mount request to the server, then below procedure will come into the picture. First one, open TCP connection for a port map using get port happened. After that, mount protocol will send a request using 635 port. During the mount request, below check happened. First, look up for a root directory. Then authentication happened. Then UID GID check happened. Then lookup call gets sent to the server for a mounted directory. Then authentication happened. Then UID GID check happened. Once all the server side check happened, then volume gets mounted. The syntax for mounting the volume is, first we have to give the server IP address or DNS name, colon, then the root file system, colon, then exported folder or file system or volume we have to give, and the last one we have to give the mount point where we have to mount the file system.
What are the processes happened when any request, that is read or write, goes to NFS server?
When you send any request on a mounted NFS volume or NFS file system, then below things happen. We have to see. First one, NFS TCP connection will get open using get port. Then UID GID authentication check happened using getattr. Lookup for a root file system using lookup call. Create RPC procedure will get called. During that, authentication check for UID GID using getattr happened. Once the RPC procedure completed, then lookup call will get sent to the server for a file system. After that, write call will get sent to the server. During the write call, authentication check also happened for a user using getattr. Then write procedure using the write call. Once the write call got success, the commit call will get sent to the server. The commit call is to save the data. Once all the procedure completed, NFS TCP connection will get closed. You have to send the NFS TCP connection close request while closing the NFS connection. As we have looked at the procedure get called while any of the NFS operation from the client server. Now we will have to look at the process interaction between the client and server. When an NFS client sends any request to the server, then first NFS client take that request and form XDR packet. Then through RPC layer, this packet will get sent to the server. Server will unpack the XDR packet and send that packet to the NFS server. NFS server will send this packet to the NFS server's local file system. Local file system act on that request according to the procedure called, such as read, write, create, any. Packing and unpacking of the XDR packet is called as marshalling and unmarshalling.
So Sachin, as you mentioned earlier that NFS request goes through RPC protocol, then can you please explain what is an RPC call or request and what is an RPC reply and response?
Definitely. As NFS protocol works on RPC procedure, So we have to understand what is in one RPC call and what is in one RPC response. So when any of the RPC request gets sent to the server, so one RPC request will have 11 factors: IP header, UDP header, transaction ID, send direction, RPC version, program number, version number, procedure number, credential, verifier, and procedure call parameter will get sent into one RPC call. In RPC response or reply, there are 8 parameters are available. First one, IP header, UDP header, transaction ID, then send direction, status of this request, verifier, acceptance status, and then procedure result. What is the result of this procedure?
Okay. How request flow in local file system and in NFS file system are different?
Yes, there is a little bit difference between the local file system request and NFS request. When the request goes to the local file system, it traverses as below. Application sends, first one, application sends a call to the operating system kernel. Operating system send that request to the VFS, that is virtual file system layer. Virtual file system layer send that request to the local file system, that is the ext or FAT or any of them. And after that, action happened on a physical disk. Now we can see what has happened on the DFS or NFS request. So application send a call to operating system kernel. Operating system send that request to VFS layer. VFS layer send that request to NFS client. NFS client form a XDR packet and send this packet to the using RPC layer to the NFS server. On the NFS server, NFSD daemon will send this request to the server's VFS file system. VFS will make a call to the local file system, that is ext or FAT, and then after that the action will happen on the physical disk.
Thank you, Sachin.
Thank you.
It was very interesting explanation about DFS, Nfs protocol and how it fits into Osi layers. Thanks audience, thanks for tuning in. For any queries, please write to us at marketing@calsoftinc.com and stay tuned for our future podcasts. Thank you.